I think you can go ahead.
Okay, good morning. And this talk is about monitoring your MySQL server's health trends. My name is Igor, and currently working as enterprise support engineer at PlanetScale. A little bit more than 20 years of experience in IT, the last 15 years mostly working with MySQL and MongoDB. And the idea behind this talk is why a MySQL database server will need a regular health checks. What are some of the server status variables that we can monitor to identify the health of a MySQL server? The idea is to actually evaluate less and see more and understand what are the normal ranges, what is a warning sign. I tried to build a simple monitoring dashboard that covers these basic health checks, and at the end I would like to show also with the help of AI how that can be evaluated to give a health score similar to how you get a score, for example, when if anybody has gone to an Olympics competition, I will try to provide the similarity. So the main idea is that it should be something like going to a regular doctor's appointment when you are not feeling well, but the doctor can't really say until they do a blood test and actually evaluate what is in the normal range, what from the results doesn't look good, and then they can actually see what comes next. So this is not going into details, it's just to see what might be wrong, like that primary healthcare that you get. It's not about going to a secondary, and it's not about going to a surgery, right? Just the beginning. And with early detection, we can prevent serious problems. So the database needs the same approach. And again, regular monitoring may allow you to identify issues that after the users start complaining, it might be too late, and just watching those metrics should give you idea what's going on, whether you watch on a daily basis or over extended period of time. Try just to give some medical analogy, but this is about evaluating your server, first beginning with the server status, then going what is operating in a normal level. And a normal level in many cases means that if you have a baseline of metrics, if something goes above 10% of the baseline, then it usually means that there is a variance, so you should be looking at those metrics. In some cases, those 10% might be 15%, so that, again, it all depends, but usually a variance of 10% over a metric means that something has changed. The first thing, evaluating, and this is a metric in any database system. Now in MySQL C schema, it's very easy, and this is just select count from the tables that do full table scans. If this returns greater than 0, it means that we are doing full table scans. That is not good, especially if the tables are big, as with binary search, we probably can find the result in less amount of steps. If we do a sequential scan search, then we will need a long time. Additionally, what comes costly with this is we are doing reads from the disk that are unnecessary, loading into memory that is expensive, and also that has to go through a CPU cycle. So this is something that's easy to check, and if this counter returns greater than 0, then we can go into further details, just selecting what are the objects and how many full rows we have scanned, what is the latency. The next thing, indexes. Indexes are good for helping us to find the rows faster, but are also expensive if we are doing write. So every index on every write, insert or delete has to be changed. Sometimes even on updates, not necessarily. But another metric, just selecting the count of the C schema where we have redundant indexes. And MySQL did a good job where it's showing us what is the redundant index, what are the columns, what is the covering index for this redundant index, and what is the actual SQL drop index command. So we have everything in this view to actually take an action. But the initial metric is just taking account, and if this returns greater than 0, it means we have redundant indexes. The next one, similar to redundant, unused. This doesn't have to be that the index might not be used, but it's just a metric that may show you something. If indexes are not used at the time that this server is evaluated, and this metric is reset after the server was started, we can just look at this. There is an option in MySQL to set index invisible. So if we set this index is invisible and there is no impact to the application, then we can drop the indexes with the same command for outer table drop index. And it's just a matter of not having all those costs, additional costs when we're doing writes. The next metric that is probably showing a good indication about the efficiency of our queries is how many temporary tables we create in the server when we execute statements. So to put this into perspective, if we have the fastest NVMe drive that has about 50 microseconds latency, and we compare with RAM memory that has 100 nanoseconds latency, that is basically on a human scale a task that you can finish in 1 minute, or you have spent the entire day taking 8 hours to actually execute a job. That is the actual difference between if you have temporary table that was created in memory compared to temporary table that had to go to the disk. So this metric measures how many of the temporary tables were created in memory compared to how many of the temporary tables were created in disk. And sometimes there is no, we cannot avoid temporary tables to be created on disk, but it's good measure to keep track on. Usually it might be just that the temp table size is too small, so these things can be set per session. Not every session have to have the temp table size large if we know that in a particular query we need bigger temp table size, then we can just increase those variables per session. And visualizing the metrics should give us better understanding how much of the total temporary tables are created on disk compared to in memory. Just plotting those metrics is not enough, or at least it's not trivial to see what's going on. But if we put both metrics and try to extract what percent of the total temporary tables were created on disk compared to in memory, then we can see that this number is really low. Ideally, this should be at 0, but that is just ideal case that will know at no time will be on an actual server. So what is the acceptance here? How much we can afford? Again, if this is in the 10% close to the ideal value, it should be acceptable. Sometimes there might be even cases where we can say we can accept even to 20% temporary tables on disk, but yeah, that is the difference between a task that can be done in 1 minute compared to a task that you will take 8 hours to finish the exact same task. And yeah, it depends on the actual workload on the server. So if we have something like this, then we're clearly having some sessions that at regular times create all the temporary tables on disk. So this is the second part of the evaluation. So the first part, what is the health? This shows that, okay, something's not right here. Now the second part is we need to evaluate the workload, we need to evaluate the queries, what's happening at all these intervals. Maybe we can just increase the temp table size to that particular session so it doesn't create all the temp tables on disk, or maybe it's just some group by with text or block columns. Those things need deeper evaluation. This is just the beginning that, okay, something's not right. Aligned with the temp tables creation, this is another metric that shows the sort merge passes, and this shows the total percent of sort merge passes. So it means that the sort buffer size was not big enough to serve the sort operation, and the sort operation had to use file usage. So it had to go to disk basically. If we have something like this, well, that matrix is almost ideal. But if we have something that at one point it went up and it's nearly 20%, that also means that we're doing disk I/O. It's expensive and we need to evaluate. So this is just a metric that is showing something went wrong with this instance. Going to log weights. This is important metric that should show us if there is transaction contention and there is locking on the system. InnoDB role log weights, this first metric is showing how many operations on InnoDB tables had to wait for a roll lock. The next is roll lock time, and that's the total time that the operation spent acquiring roll locks. So we can have just 2 operations that were waiting 50 seconds, that's total time of 100 seconds, or we can have 100 operations that are waiting just 1 second, and the total time again is 100 seconds. So we need to understand here, comparing both, what is the total roll lock wait time and how many operations are actually waiting. So we can understand about the contention in the and the locking on the InnoDB engine. And if, again, ideally this should be 0, but if we something that is going above our baseline, we need to define the baseline, then evaluating this additionally, then checking whether the transactions are long, whether the transactions are locking additional unnecessary records, that different threads might be waiting for those records to be unlocked. That is something that we need to evaluate further. So this is just the baseline, what is the health. Going further, connection utilization. On this graph, we are seeing what is the max connection setting on this server, how many threads are connected, and how many threads are running. It doesn't really show a lot, so a different view is what is the actual threads connected to the max connection setting. And if we have 100% at max threads connected, but we see that on this server we are at about 20% of the connections utilization, then it means that this system is running fine, and this is showing a healthy metric. But the next thing is actually how many of the threads connected are actually running. And this is, again, if we compare, the 100% is all of the threads that are connected are running. So this means not healthy system, or this might be healthy if it's just for a short time, but this should be maybe somewhere below 20% of threads running to threads connected. If we see something that is 40-50% going to 80 or 100% of all the threads that are connected running, but again, on the previous metric, we see that all these connections are going up to the connection utilization of 100%, then we need to see what's going on and why we have that many active threads on this system. It means that a lot of threads are executing queries, so maybe our queries are slow and it takes time. We may be low on CPU, so that is the next thing of the evaluation. But this is just the beginning to show, is this healthy or it's not healthy. Important metric for the write throughput on InnoDB engine, the redo lock capacity. This comes with some defaults, and on most systems will be fine, but sometimes it's just not. And this measures the lock sequence number growth rate. And if we have 1 gigabyte of redo lock size, there is a mechanism in InnoDB that has fuzzy checkpointing, and at 75% of the redo lock capacity, it will not block the writes, but the flushing from the InnoDB buffer pool will be just in the background. As we approach this line, then InnoDB will start pausing the writes, and it will start flushing more aggressively. If we go above this line, and we are close to 87.5% of the redo lock capacity, the writes are stopped, so until the flushing is enough so that we have low redo lock checkpoint age. And in this case, we can see that here the numbers are showing the redo lock size is just too small and this system is not healthy. So that's what we have to evaluate, whether the redo log capacity is showing healthiness or not. And on the other side, we can see that the redo log was increased to 4 gigabytes, and then we see that the checkpoint age is not even close to the async flash point. So that means healthier system. And finally, the last metric, the buffer pool hit ratio. This is showing how many of the reads are logical reads and how many are going to the disk. If we compare both total logical and take the on disk and put that into a hit ratio, this ideally should be 100%. But from ideal 100%, we should evaluate a system. How does it behave over time? Does this look like a healthy system or not? And maybe for a buffer pool utilization and hit ratio, it makes sense that we are above 95, so that 5% drop is acceptable. But if we see that at times this drops below 90%, that it means either we might be doing full table scans, so we drop a table and then that table is not used and it flushed out rows that we don't need in the buffer pool, or the buffer pool is just small and we need to size it up. So that's on the second level of the evaluation. The first level is, should this help us to identify that something is just not about right with this instance. And for the buffer pool, yes, so this is maybe if not the most important, but a metric that is definitely something to look at and take actions. It should show us a lot with the workload, but at the same time, all of the other metrics that we mentioned, whether we have full table scans, we have unnecessary indexes that we update, a lot of pages might be in the buffer pool that we don't actually need. So it does require having the full picture. And putting all of the metrics in a single dashboard where, again, less should be more. We don't want to evaluate everything, but we want to see whether we can tell if this instance looks healthy or not, just by comparing with a baseline and reference numbers. There are numbers that should be ideal case, like we don't want row logs, we don't, like this should be 0 ideally. We don't want temporary tables on disk, should be 0, but if we see that, okay, this is less than 1% of temp tables on disk, does this show us some healthy system? The full table scans, how many full table scans we have on this system right now? How many redundant indexes we have that can be covered indexes? What is the number of unused indexes that we have? The buffer pool hit ratio, how does that look, and the redo log checkpointing. So by looking at this, we should just have something in mind. How much of all of these metrics will reduce our score if we say that, okay, we have a total perfect score of 10 and we start with that. And the idea behind this is, and this is just like a playground right now, but if you compare this with how the Olympics score system works, contestant goes and initially they get 10 points, like whatever you did is perfect. But as you start doing any exercises, there are judges, usually more than 6, but at least 6, and they evaluate what is the difficulty of what you did and whether you did it with mistake. And then you get points dropped if you are doing a mistake, but at the same time, what is the difficulty? So if we put those scores with points, like we have full table scans identified, but how many actually, like whether it's 1 or 10, how many redundant indexes we have identified. And that depends whether it's high severity, low severity, or critical, medium. And the same if we look at all of these metrics and we start reducing our score, then we get a final score, and based on that final score, we can interpret the score. So 10 being, yes, this system is perfectly healthy. By reducing points, we come between 9 and 10. Yes, this is healthy, but there are some minor issues that we need to address. And then going down, whether this is completely unhealthy system and we really need to take actions. So with those metrics and just by doing score with reducing points, we can have at the end some score that will tell us this system looks healthy or this system really needs attention. And finally, taking actions. So full table scans and unused indexes, temporary tables. At the source of everything is that we are sending queries to the database. So the first thing is just look at the workload, how many queries we send, how long we have our transactions. Maybe we need to reduce the transaction scope. Maybe we need to use connection pooling. How much of the workload is write workload compared to read workload? And do we have sufficient memory? Do we have sufficient CPU? And that should take us to the next step where we take actions and then we go back. So after some time, we analyze the system with the same health checks. And that's all. Thank you.